Okay, good evening, everybody. Pleased to start the Dorkbot Cardiff number 16 session. We've got a pretty cool lineup tonight with 4 speakers, starting with Sunil Tagore. Is that the way you pronounce your surname? Who is going to tell us about his work with open source tool and 3D printers. Okay, what else?
Hi everyone. I wasn't sure if to use the mic or not. I've used the mic before. Okay, going to talk about 3D printing mainly, but generally about open source hardware and where 3D printing tools fit into that sort of process of building things in a more sustainable way. So the rationale for this project really is sort of looking at different ways of building things. And the way I see it, the problem with mainstream building is it's very centralized. It's a sort of what was known as cradle to grave sort of process, where things are sort of a bit of a black box, a lot of technology, you don't know how to repair it or maintain it or fix it. And as a result, it just gets thrown in the bin into landfill. And there's a lot of embodied energy and carbon emissions and a lot of mining and all kinds of really bad stuff in getting our technology. So one sort of possible way to sort of reduce that impact is to use things like, well, broadly to reuse things, and as you know, reuse and refit and mending, repairing things is very important. But also redesigning the things we need and using open source tools to do that. And the reason for that is, like I was saying before, a lot of technology is a black box, so you can't get inside it. And by using open source tools, there's a greater chance of us being able to get inside and figure out what's going on and maybe build an interface or something that's kind of compatible with something that already exists. So, I guess it's sort of getting more involved with the making process, the maker movement, that sort of thing, and getting a closer connection to the things we consume, whether that be food or, like growing food projects, local growing projects, or, building things more locally. I think that closer connection to what we consume is important, because we know what's gone into it, we can appreciate it more, and there's a greater chance that we can maintain those things better. So, has anyone seen iFixit website? So this is a sort of really great example of, they have manuals online on how to fix various sort of fairly high-tech stuff that would normally be really inaccessible to fix. And the way I see things like 3D printing and other sort of fairly high-tech digital fabrication tools fitting in is what often happens with a lot of things we buy. You might be able to take it apart and have a sort of figure out roughly what's gone wrong with it. And if you're lucky, there might be some other manuals like this, on how to fix certain things. But occasionally there'll be one component that's been built really badly and has purposely been designed to break, because a lot of centralized mass manufacturing relies on inbuilt obsolescence of certain items. So they're actually designed to break very quickly, and they don't want you to fix it, basically, because then it means you can't just buy the next upgrade or whatever. And so I think 3D printers can build these kind of, fill that gap and make very specific items that can fix things, but in conjunction with sort of moulding and using other materials. In itself, at the moment, most 3D printers sort of on the DIY end use plastic, so the sort of real world applications are quite limited. So in conjunction with moulding, metal moulding, I think that could open up a lot more possibilities. But that's not to say there are lots of applications at the moment, but they're still at their very early stages in terms of development. Yeah, can you see at the back like that sort of writing, or yeah? So yeah, check out that website if you need to fix any things, and get in contact with someone who's got a 3D printer if you want to make a part to fix something.
Do they have like 3D models on the website, or?
I don't know actually. I don't think they do. I think it's more like repair manuals. But that's, yeah. I mean, I'm sure that could happen at some point.
Yeah,
this. It could be something like, this item has this problem all the time, and it needs this replacement part. Here's the CAD file to it, print one out, and then your item will last forever.
I'm sure there's many sort of open source websites where you can get that sort of information as well. So if you've got a component you need to use, you can go to a certain website and you get a digital file and you can print that from that.
Yeah.
So I'm sure these problems sort of get solved by a lot of people as well. So your washing machine breaks down, you need a new cog or something for it, it will work for it.
Yeah. I think I'll stop using the mic. Can you hear me at the back? Yeah. So yeah, that's sort of how I think there's been a lot of hype around 3D printing, and the applications are still at this sort of fairly geeky end of the spectrum, and the real world applications are still sort of brewing. So I think I've mentioned some of these points already, but 3D printing is just one of many tools. It's not going to be the answer to everything. I see something like this sort of being in a sort of community workshop where you've got other sort of cutting tools or lathes and all the rest of it. Basically, it's only useful in certain situations, like a head tool, like a hammer. So what's really great, I mean, I don't know how familiar some of you are with 3D printing, but one great thing is the complexity of objects you can make, and the sort of, you can sort of code objects and use sort of mathematical algorithms, incorporate that into your objects, and it can be quite powerful in terms of making a sort of generalized object that can then be applied to lots of different situations just by altering a few parameters here. And it could be, one example could be like these are sort of water wheels. I work in hydropower at the moment, so I'm just playing around with some ideas on how to build certain types of water wheels for certain situations, because each situation is different. You tend not to be able to find suppliers that can build the correct size turbine for a certain flow of water and a certain height of water. So then something like this, an algorithm that can build a turbine based on your flow and height of water can be quite and the speed of the generator can be quite handy, because otherwise it's quite difficult to design that sort of thing. As you know, you can email these objects around the world. It's just an electronic file, and there's standard kind of formats for doing that, and lots of open source CAD programs out there for everyone to get involved. You can modify these objects as you go along. And I think it's going to be a slow process to get from where we are with technology, and it's fairly centralized still, to sort of being able to really redesign things and sort of start building up more things locally. So you can see. So this is the RepRap printer. The RepRap project started in 2005 at Bath University, and it's what's known as fused filament fabrication, which is basically like extruding molten plastic through a heated nozzle and to form an object. So all these objects are being made by sort of slicing up a 3D model and then sort of putting layers of like plastic, and it sort of builds it up layer by layer. The RepRap is sort of known for being able to self-replicate. And the way it does that, in a sense, it prints a lot of its own parts. Because of that, potentially it can grow exponentially. I think there probably are tens of thousands of RepRaps worldwide. I don't actually know the number, but I think there's a lot around. One analogy for the project is it's sort of like a symbiosis between people and machines, in a similar way that bees drink nectar and pollinate flowers and get nectar in return. We look after machines that give us objects that we need. So it's a kind of ecosystem in that sort of respect. But the RepRap still needs things it can't make itself, like step motors and electronics. But and those are sort of known as vitamins, things that you can't fabricate yourself. In the same way humans can't make certain vitamins, but we can self-replicate. So the RepRap project development takes place on a main wiki, and then there's various blogs and forums around that main list, an IRC channel, and there's various sort of user groups around the country that meet up and build sessions, and it's published under the GNU GPL open source license, so nobody can patent it. It's great. And then at the top was the first one that was built, and then the sort of second generation was the Mendel, which took on a sort of triangular frame. And then since then there's been a massive explosion of different types and variants, and lots of commercial spin-offs. it's recently been taken up by RS, which is a massive electronics company, and they sell kits to build a derivative of the rep wrap. And the tool chain that I'm using, it basically takes a standard CAD file, which could be any format really, but generally there are sort of standard de facto formats that a lot of people use. And there's various sort of open source tools, but basically it slices up the objects layer by layer and then creates a tool path. And then it sends that data to the firmware, which then controls the step motors, tells step motors how to move, and what acceleration, what temperature, what extrusion rate, and then it builds up the object. I can show you I'll give a demonstration now, so I can show you how that works. And then, some applications I've been looking into are I sometimes occasionally fix various everyday objects. Occasionally, a piece of furniture broke, I had to make a little weird fitting to get the two bits of wood to connect. Printed out little buttons to fix an intercom. Nothing special, but it was good to be able to fix something and not have to throw it away. And then I've been looking into aerofoils. When I was working at an educational charity a few years ago, and I met up with an open source organisation who wants to build an open source wind turbine. So one possibility was, one problem they had was the blades. To build the blades, you need a mould. Building a mould is a very difficult thing. It's quite hard to get hold of a mould to be able to build blades of a certain size or whatever. But there are libraries for describing the profiles of blades. So one application is to use these libraries, print them, and then create a mold from these profiles, which should be almost impossible to do by hand. It'd just be really, really difficult to know how to profile a blade. These are hydroelectric parts, but need to be molded. You wouldn't really use them as plastic unless it's a very low power system, so it would have to be molded. And then some other applications I've been looking in, which are a bit different, are control systems and transportation. But that's sort of digressing a bit. What's missing here? I wanted to just talk about this object in the corner. To me, this sort of embodies maybe where the 3D printer fits in. It's what they call the free universal construction kit. It's basically like Lego, but bric-a-brac and all the other, Meccano type things. And they're not intercompatible. So the free universal construction kit made objects that can cross boundaries between all these standard objects. So this is sort of one way 3D printing can help sort of connect different sort of items together in a way. So we're not going to be able to sort of do away with certain technology because it's so widely spread, but we can build things that can help us connect objects or connect technology in a way. Yeah. I'll show you some objects. So yeah, this is MeshLab, which is an open source CAD program. Well, it works on, as in the name, it's a mesh type CAD approach, which personally I don't use that much. I'll use something called OpenSCAD, which is a parametric approach to building things. So instead of having a mesh that describes the object, you have equations and sort of primitive shapes that you add and subtract to build up an object. And the good thing about that is it can be quite hard to start to build the object initially, but once it's built, you can change things about it very quickly just by changing a few numbers. This is a library for profiles of aerodynamic blades. Just to give you an example, like if you were to build that as a mesh, it'd just be very static. You would be able to change it very easily. But if you build it using equations, then you can just change a few parameters in it, and then you can change the sort of thickness of the blade and the curvature of it. When we compile that, you can change things about it much more easily. So if you were building a wind turbine and you needed certain aerodynamic properties, and someone said, yeah, if you've got this wind speed, you need this sort of blade. Here's the equations for the blade. Then you can render the blade, build a mold, and build your own wind turbine. So yeah, that's about it really. I'll switch it on later when maybe at the end of the evening, and then you can see it printing.
Can I ask, is this software completely code, or have you got? Because I use SolidWorks, which is all of it's just preset tools.
Right. Yeah.
It's a case of interacting with the mouse. Hardly any keyboard presses. That looks like it's all code. Is that how you?
Yeah, it is actually. Yeah.
Right.
Yeah. I think it's. Yeah. You write all the code on that side and just compile it, and then it just renders it straight away. Yeah. So this for example, this is you can see it. It's actually a weir for a hydroelectric system. I've been trying to parameterize it so that for a given river of a given width, you can divert a sort of fixed flow of water from it, and it will sort of render the design that you need to put in there and build your weir.
So you would enter like the width of the river, the depth, speed of current, and that informs your design?
More or less, yeah. The width and the depth. You'd probably have to have a rough idea of what you're doing, but it would help a bit, I think, in designing it.
And then I guess in presenting this to the wider world, would you be able to strip down all that information on the left to just what's essential. So, for instance, like
Yeah.
enter your wind speed here for the plane.
Yeah. Exactly. Yeah. And you could literally parameterize it down to some very simple things, and then it will tell you what you need at the end of it. Yeah.
So you actually like the product?
Can I just ask about the fabric?
Fabric. Oh yeah. Material.
Yeah. Is there any flexibility in the material, or is there
You can use a variety of plastics. I think most people in wrap are using two types, PLA and ABS. PLA is starch based. It's a bit more brittle, has a lower melting point. ABS is a mineral-based plastic. It's got a higher melting point, but it's probably more durable. Well, it is more durable. But you can potentially use all kinds of plastic, all kinds of thermoplastics. You just need to work on the settings, tune the settings for the specific melting point of the plastic.
Forensic extended message is your had later been removed from the crime scene sample zone and its chunk of it has gone missing. The tourist seems to like to feel like
There are printers, material printers, which print with material rather than plastic, so they're used for rapid prototyping of fabric designs. Where it's a similar thing, you have a computer program, you type in the pattern, and it mixes, it can do makes materials as it weaves, and it weaves your clothing with all the markings on it. It's very similar setup, but
There's a new plastic just come out as well recently. It's almost like rubber, but it's metal molding. So it's, you make shoes and sorts of things. So it's real squishy. Like shell cases.
And the Pirate Bay launched a 3D printer section a year or two back.
Oh yeah.
So you can download designs and manuals. And the Army started deploying 3D printers in the field now. The American Army. And they're using them to fix things. And NASA's printing parts for the new Moonlander 3D printer as well. It's meant to be cheaper.
It's been used a lot in industry. It's been used for a long time. It's only recently it's become more, because it's been open sourced,
More democratic.
More accessible to build the DIY kind of approach.
So I know you were working in Africa quite a lot, or you have in the past. Do you use these sort of technologies down there?
I haven't really got that far yet. So I've been working recently in Uganda doing water projects there. We might be able to sort of print out some of the parts we need for the hydro system, but at this stage it's difficult to know, where it fits in and what sort of applications it's going to be really useful for. But there are some possibilities, but still in their early stages.
Okay, thanks.
Yeah, great.